Hey, good morning, everyone. Thank you so much for joining one of the another session. I have been joined by one of my best friend and bro, Rahat Yashir from Montreal, and I'm Deepak Kaushik from Bridge City of Windsor, Ontario. So we are. Thank you again for joining on Canadian MEP show. We have been doing it from 7 years, and thank you so much for all the audience who are joining from different platforms. So we are so excited to have you here, and we will going to talk about some of the interesting things which have been asked to us from while on AI Prompt Flow and Azure Fabrics. So thank you so much, and let's start. So I know it is weekend, and every one of you who join in such a large number, we are always grateful for that. As you know, me and Rahat are Microsoft MVP. We have been presenting across the globe from while. Related to me, I'm contributing since 2008, and we both have been on various platforms like C Sharp Corner to DevOps Labs and another thing. So thank you so much. And Rahat, let me make you presenter, and you just go from there, and then I will take the control. Is that fine?
Perfect. Thank you.
Sure. Let me do that. You are
So while
first
you're
now.
doing that, I'm just gonna quickly introduce myself.
Hmm.
Thank you for attending our session. And my name is Rati Asir. Currently I'm working as the head of data quality and analytics at IATA, which is International Air Transport Association. So all the airlines, airports are sending data to my team. We call it the GADM, Global Aviation Data Management. And the yearly accident report that you see of our of all the airlines related plus of all the regions is prepared by my team. Plus
Interesting.
also, yeah, plus also, like, we host some programs like flight data exchange, incident data exchange, maintenance cost data exchange. A lot of airlines are contributing data to our platform to get some sort of like anonymized reports. What is happening in the world? Which region is having more flights, less flights, or issues, or those kind.
Wow. So
Sorry.
it is
Yeah.
it is so great, Rahat, and thank you for your great work which you are doing and making so many users' life easy. And
Yes.
Rahat is among the top 10 speakers, and um, in AI side, he is one of the incredible guys. So I just want to share that.
Thank you. Thank you, Deepak. But in today's session, like, we are not talking about aviation. We are just like talking about Prompt Flow. It's a new tool that Microsoft has launched under Azure AI or Azure Machine Learning Studio. So how can you use Prompt Flow, and what is Prompt Flow? So the first thing is you need to log in into Azure. You need to create an Azure AI workspace. Once you create that one, you need to log in into Azure Machine Learning Studio, which looks like this. Once you're into the Machine Learning Studio, the prompt flow is just under the authoring section. Once you click it, you see the prompt flow. So I already have some prompt flow that I was trying, so you can see those examples. So what is prompt flow, and what type of things you can do here? So when we are interacting with a GPT model, sometimes we are asking for, hey, can you summarize this text, summarize this email, find out the key points of that email, translate it from English to French. Or when we have a bulk of information and we want to find out some sort of classification, Q&A, tell me what are the like answer related to this document in this type of like text or something like that. So you use prompting with your GPT model, but those activities are mostly manual. Can you automate all those activities? So to automate those prompt related activities with the GPT model, Microsoft has launched Prompt Flow, and they have also integrated it with the Azure AI Machine Learning Studio. So what type of like a prompt flow that you can create? There are three types of flow that you can create. First one is standard flow, chat flow, and evaluation flow. So we mostly use the standard flow where you need to connect your GPT model first. Sometimes you also need to connect the like text embedding like a model as well. And then what you can do is you can use the power of LLM or model, and also integrate Python code, add your different types of like prompting or prompt version within a flow, so that you can do multiple work in a single activities in a single flow. You don't need to like have multiple calls in multiple places. You can combine all of them in a single process, and then you can also deploy it as an endpoint. You can use it as an API, you can use it as a tool. So this is one of the like a standard flow example. But at the same time, you also have the chat flow and evaluation flow. On the chat flow, it's similar to standard flow, but on top of that, you can have you can do debugging, you can have chat bot kind of interface. If you want to deploy a chatbot, you can test the communication, the process, the interaction of that flow of that chatbot through this chat flow, so that you don't need a different test environment or dev environment. So you can host that dev and QA environment in the prompt flow. And then the evaluation flow is when you want to like test an GPT model. You have some expectation after the training. Is your GPT model giving you the right expectation, right answers? So you cannot just like train a model and then deploy it and then let people use it, because sometimes GPT can hallucinate. It can give wrong information. It can give unverified information as well. So in that case, it is extremely important to test your model, have content filtering, like have guardrails, so that your model doesn't give garbage information. And you can achieve those things by having the using the prompt flow too. Some of the examples are given here. You can see you can have multi-round Q&A. You can have web classification, chat with Wikipedia from a with a web like HTML page or some sort of like Wikipedia kind of like a content. You can have other types of like Q&A activities as well. In this case, what we will show the demo of is the web classifier. So you can just like click clone and then create that one. But in our case, I have already created that one. So web classifier is this one. So why I'm showing an existing one? Once you create that, you also need to have a runtime where your okay, my runtime is gone. Okay, it may take a couple of minutes where your code is going to run. And you can see I just like clicked start runtime, and it's saying it will take 1 to 3 minutes to start the runtime. So I was using an existing one, but it looks like I have a 30-minute shutdown policy. So it kind of like shut it down, or this in this case, it's 1 hour shutdown policy. It automatically shut it down. So before we run it, we need to see what are we achieving with this web classification. So the first thing is we have, you can see a graph, you can see a flow. So it takes an input. Okay, that is good. Input can be a string. Once it takes an input, which is a, and that string is a URL. So once we give the URL, we have the first code base in Python or first module, which brings all the textual content from that URL. So it's like a web scraper or something. Okay, that is good. You have all the text of that URL in your prompt or in your flow. And then we are saying, summarize this text, summarize this entire text content that we have. Okay. And we also like have similar examples that we are providing. This type of summarization is application. This type of summarization is channel or TV channel related. This type of summarization is academic. If it doesn't follow one of them, it is none or none category. So I'm also giving some example as well. And then what I'm doing is I'm giving LLM first task of the LLM is summarizing the content. Okay. Second task of the LLM is take this sample, take the summarized content, combine them together, and apply the classification according to this example. So whatever URL that I'm providing, it is getting a summarized output or like a summarized version of all the content of that URL, and then making a comparison with the sample, and then it's saying this URL is a app type or channel type or academic type or none type. So this is the main task. And at the end, on the output, we can get the final output of, oh, what is this URL type about? Is it sports URL or something like that? So it's a web classification. Sometime when we do some sort of like here we are using multiple use cases of LLM here. First one is text summarization. Second one is uh, text classification. But on top of that, using it as a tool, uh, doing that like crawling using our Python is automatically also happening. Converting all those like classification into text is also automatically happening. So in a single place, we can do one, two, three, four, five, six tasks. Where if you do it in your through some sort of script or something, you had to do write six different script. And in this case, we can combine all those scripts in a single graph. Um, and one thing just to mention, we can also write our Python code in this case. So while our runtime is getting started, I will just show what type of Python we can write. So you can see we are adding the prompt flow. We're also adding BS4 request, and like its request is more into like API request and response related. We are also providing the all the information regarding the HTML parsing, and we also like all the sample thing codes are already written. It's already provided. You're also like providing that if it is if you get response ID 200, what you're supposed to do. If you don't get the response ID 200, which is like a false under response 100 or something, what type of message you are supposed to give. You're providing the sample, and also you are also providing any other types of like Python code for classification that you need to provide. So all those things are already there. All you need to do is use it and then classify different types of text. So
Amazing.
first one is Wikipedia Super Bowl. Instead of that, let's go to like Avatar Wikipedia movie. So I'm just like getting the link. So you can see this is a Avatar film, very popular. We all have watched it. So this is the link of that Avatar like a movie. So let's see what happened if we provide that one in this URL. This is the exact URL, nothing else. I'm just like running it. You can see this prompt flow is using this runtime, and
Mm-hmm.
I have already connected the LLM GPT models before running it.
Quick question, and when you are saying LLM, what you are
Large
referring?
language model, similar to like a chat
Okay,
GPT. Chat GPT
that's
is a chat version, but the GPT models of the chat GPT is already
okay.
connected. So you can see the run is completed. So
Mm-hmm.
in this case, what has happened is we have provided this avatar link.
Mm-hmm.
It has it got all the text regarding the avatar. So you can see all the avatar type of information is there. It's a big text, and then we are kind of like summarizing it. This is the summary of that entire page. We cannot see the entire page because it's too big, but we are asking the LLM, please do summarize the following text in 100 words. So it
Okay,
has summarized it using the GPT and prompt flow, the Wikipedia page for the 2009 film Avatar. So you can see that this is the summary.
good.
And then we are providing the sample of classification. What type of text is app? What type of text is URL? What type of text channel? What type of text is academic? That kind. And then I have given the sample to our GPT, like a prompt flow, and this is the output we have received. So output is saying category movie, so it can detect what type of category it is of that individual URL. Now if we say uh, cricket World Cup Wikipedia page, and what happened, I'm just like writing it by the side. So suppose this is the cricket World Cup Wikipedia page, so this is sports. So this is the page I talked about, so let's copy this one, and then I'm gonna just provide this and then run it. So last one was movie. Our prompt flow was able to like detect that one, that it is a movie. It fetched the content, it summarized the content into 100 words, it used it in a classification based on the samples, and then it detect what type of like URL is that as a web classifier. So it is done, run completed. It also like did the similar kind of thing. You can see the cricket World Cup, all those like text from the Wikipedia page. This is the 100-word summary, and then the sample that we have done the classification. It's academic, so it's not saying movie, but I didn't provide any sample sports type. So here, if you remember, there were only there were no sports type sample. That's why it didn't detect the sports category. So it detected the academic type category in this case. So you can use it for any other types of, not only Wikipedia, any other type of web classification. Or suppose you're getting a lot of emails in your customers support email box. Sometimes emails are issue, sometimes emails are featured, sometimes emails are related to complaint, sometimes emails are related to feedback, sometimes emails are related to rating, or sometimes are they are just regular queries. So you can build a classification model like this, where your this prompt flow model will automatically get access of your email box, like get the email right away whenever it's coming from the inbox, convert it into HTML to a text parser, and then from the text summarize it. And then it can also like use this type of classification to say this email is based on feedback or complaint or rating or general query or something like that. So if it is a general query, your like customer support related to general query will automatically get a summary of that one, so that they can respond. Or if it is a complaint, the supervisor or manager can get a summary of that email and then can act accordingly. So you can apply this type of like customer support flows and test them on prompt flow. And they're super easy to use, they're super easy to deploy as well. You can just click, you can deploy it within your Azure ML, you can have a new or existing endpoint. It's very easy. It's super easy to
Amazing.
deploy and use it as an API endpoint as well. So that was a simple demo of prompt flow. If anyone has any question, feel free to ask.
Thank you so much, Rahat, and for all of us who join from Saskatchewan to Detroit to Ontario. Like it is really very incredible. And for me, who want to build his knowledge base around AI, it is always a blessing. Thank you so much, Rahat.
Perfect.
Okay, now we will talk about another topic, which is fabric, which is getting a lot of attraction nowadays, and certainly we will gonna to talk about that as well. So I believe you guys can see the screen.
Yes.
Okay, okay. So as we already talk about AI prompt flow, now we will talk about fabric. And for fabrics, if you remember last year as well, we did a couple of sessions around fabrics, and we are getting more and more attraction around that. So we will talk about fabric is the uh, how we could define and what are the different services. Like fabric is could not be considered only one service. It is the combination of one lake house, data warehouse, science, real-time analytics, fabrics, copilot, etc. So basically for everything. There is common question coming about, hey, how fabrics are related. You could see screen where we have the different options like mapping, workflow, SQL instance, data warehousing. If you remember, it was SQL data warehouse earlier, machine learning, data set. So basically, it cover each and every aspect of that, from ingestions to transformation to analytics purposes, to further extend it into the AI and machine learning. So Fabric is uniform platform that bring all the data and analytic tool together for the organization, and that can go from data lake to business user. So it is the combination of Azure Data Factory, Synapse, Data Explorer, Power BI, and Data Activator. So basically, for every perspective, it is one of the solution. So if you have to understand the fabric, you could think of it as the PBI workspace and adding the SaaS version of Synapse of it. It is aligned to backend fabric capacity similar to the Power BI capacity. So it has data warehousing unit, which we were using from a while. In Databricks, it is DU, Databricks unit. So just consider it is the serverless pool and dedicated pool. Uh, and if you required your organizational side of it for Fabric. So that is so important. For personal, it is not available yet. So Fabric make everything simpler and faster. Earlier, we have to provide on left-hand side. You could see so many options like subscription, resource, and storage group and whatnot. And now you have to only give the name over here for data lake, and you will be all set. And for Synapse Workspace, this is the left side. You have to provide all the detail, but now you have to give data warehouse name and everything will be taken care of. Left is older version in Fabric is this guy, so it is always important. It will cater all the requirement of engineering side of it, being architect, team who work always on data factory warehousing. They could work data science could engineer data scientists can work on data science and machine learning. Azure machine learning, Rahat is you know phenomenal over there. Data analytics for Power BI analytics and data's democratization where on Microsoft 365 Power BI. So basically, it is a combination of all the services come under one site, and it serve data via warehouse or lakehouse, serve transform data, and serve via embedding. One lake is you could consider it one lake as your OneDrive or Google Drive kind of thing where data will sit over there. So basically, you don't need another lake house. You just keep one lake, and it could have the different flavor as well. From workspace A to workspace B, from one storage to another storage, you don't need to do so many things to connect over there. So basically, that is taken care by one lake, and it will make our life easy. So you could see this is the one lake over here. You could keep that drive, and in this drive, there are so many things over there. So basically, it will sit in your machine as your Google Drive or OneDrive, and you could perform those things. Lake house architecture, we have been talking about it from while, and it is kind of one of uh, top niche functionality that come into lakehouse architecture or delta lakehouse architecture where we could manage with the acid principle where so many files. So similarly, concept bronze, silver, gold is available over there, medallion architecture, and we could do transformation, and then that will be exposed for the Power BI. Uh, this demo we already look over. You could go to the lake house, give the lake house name, fabric name, and you could be all set over there. For Synapse and data warehousing unit, as we know, for huge amount of data, we are not talking about tera data nowadays. It is petadata and more. Synapse will take care of all those because of the huge capability around same. There are the different SQL endpoints which could be exposed. So just spend a couple of times over there. What would be the difference between Microsoft Fabric, warehouse, or SQL endpoint? So licensing, if for Fabric, it would be Power BI Premium, that is for warehouse versus SQL endpoint, primary capability, ACID compliant, atomicity, consistency. We all know, I'm not going over there, and data loading. So basically, read and write delta table that is available in warehousing. Um, if you only need to read, then you could use SQL endpoints. For data science perspective, once data is available, problem identification happen, data discovery and pre-processing, experiment modeling happen over there, and then that is available for insight. Just spend some time over here. As w- in our case, the beauty of this Canadian MVP show is we never share anything theoretically. We do share real-time solutioning, which we have been providing from while. So at left-hand side, we have streaming devices for smart city. The data is coming. We are using IoT Hub or Event Hub For ingestion perspective and for unstructured or batch processing or semi-structured whatnot, we have ADF. We are using that, and that data is available into the Synapse Analytics. One, it is available, as you know, always it is recommended to store IoT data or streaming data into the cold path or cold hub or cold storage that we have done in by Lambda architecture, where we have history, trend, and analysis. And for Azure Delta Lake, we have, that storage. We all know cheapest storage available while we speak is the ADLS Gen 2. That is so important. And for processing, we are using real-time analytics with Steam Analytics, and that is over there. And for Data Explorer, we have serverless and dedicated pool. Streaming dataset and real-time dashboard is available in different things, and business user can do analysis, application viewing, and share database. It is supported by ADF, Azure Active Directory, which is Entra, Microsoft Entra now, cost management, Key Vault, Azure Monitor, Defender, GitHub, etc. So if we look over this in holistic way, let's talk about from principle of well architect framework. Are we taking care of cost optimization? Yes, we are taking care of cost management. Are we talking about reliability? Always available. Are we talking about security? We have Cloud Defender to Entra and Azure Key Vault. So basically, from architecture standpoint of view, to all of us, it is so important we ensure our client not only get the best services, they always adhere to the well architect framework. Having said that, thank you so much. That's what we want to talk about. And let me stop my slide over here, and we could talk a little bit over there. Rahat, anything you want to add on?
No, as you said, the architecture that you showed, you also talked about the cost, the visualization, how those data will be handled, the different types of Power BI licenses as well. And again, if you handle the data well, then you can apply the model catalog, prompt flow, AI, and everything. So the first part is the data, and then all the fancy AI things comes. So this is extremely important part that you showed. Like any organization or whoever is working or wherever, so they need to handle the data first, and then they can think about sustainable AI practices. So without data handling, you cannot have a good AI practice.
Sound good? Okay, thank you so much again, everyone, for joining it. Feel free to drop a note at our LinkedIn, our X platform slash Twitter, or our YouTube channel. We are looking forward for your feedback, and we will go from there. Thank you so much from Canadian MEP Show with my best friend Rahat and me.
Thank you so much. Thank you.